welcome to this video. In this video, I'm going to talk about control chart. This is a very important statistical tool I learned in this course. I was a little bit confused because there were so many different control charts. But in this video, I'm going to help you to understand the difference between them and show you how to interpret a control chart, just to provide you an overview to build your understanding of process control. Basically, there are two types of control chart as there are two types of data, right? There are variable data and attribute data. For the variable data, we have R chart, which is used to monitor the variability in the process. We also have X chart, X bar chart. I use X chart as an example. They are used to monitor the centering of the process. For the attribute data, we have P chart, NP chart, C chart, 4 different charts. They are used to show the fluctuation about defectives in food processing to ensure food quality. Okay, right now I'm going to show you how to make a control chart very quickly. And this method applies for both attribute data and variable data. So very simple. First, you need a dataset. For example, I use a pH. So once you have a dataset, you need to calculate the control limit, including upper control limit and lower control limit. Here is a formula to calculate the variable control limit, and for the attribute control limit, you have different formula depending on what kind of control chart you are going to make. Okay, so once you have this data, you put them in the table and you select the table and you insert a chart. Here we go. Okay, so you get a chart, right? Okay, this is not a good one. Okay, once you have a good control chart, you need to interpret it. And for a perfect control chart indicating everything in control, you need to have all the points fall within the control limit. And all the points should be around the mean. No points should be outside the control limit. And the perfect one is that you have same number of points above and below the center, which is the average. All the points should be distributed randomly in the chart, and they are closing to the average. Okay. However, in reality, you might obtain a control chart looks differently, and you would want to identify them and interpret the causes of them. Just to explain why the process is not in control. So if you have a chart like this, if there is only one point outside the control limit, the source of variance must be identified and removed before you proceed. The causes could be error in calculation, measurement error, and before you proceed, a second sample needs to be taken. If you get a chart, look at this, you might have upward trend, downward trend, and even if all the points in this chart is in the control limit, this process is not in control. The causes could be operational fatigue, aging of equipment, many different causes here. There could be many other different chart with different pattern, indicating the process is not controlled. You might find a chart with repeating cycle pattern like this, or you might have a chart with points hugging the control limit, or you have instability of the trend. That all means the process is not in control and you need to interpret the causes of them, and you will learn about them in the lecture. Okay, that's all I want to talk about. I hope this video provided you a good summary of control chart, and I hope you best luck in this course.